Yes, I think it's no news that many people have reacted to the superhumanism with the thought that, but now humanism has gone too far. Uh, and and I am one of them. I think, in some sense it's gone too far. And then I think of myself and I look at my own work and I wonder how much of that has gone too far. And so what I want to do is, I don't have a great conclusion. This is sort of just a sketch of some thoughts, really. But I'll focus on Bohemianism, applying humanism to the wave function. And I'll use that as a kind of test case for when humans have gone too far. But I won't have I'll just tell you right now, the conclusion is disappointing. The answer is, I don't know. And in fact, on the subject of too far, there's different views. Says T.S. Eliot, who says, only those who will risk going too far can possibly find out how far one can go. So you can think of going too far in a positive light. But then Confucius says, to go too far is as bad as to fall short. And so being an optimistic, positive person, I'll take a kind of Eliot line on going too far, but I'll acknowledge that there is the Confucian line behind us as well. Okay, so normal humanism, well, it's about the modal, and the idea is, it just take what exists, and then I get the modal notions from systematizing the actual mosaic. It's not in the business of saying what exists apart from denying necessary connections. So you might, if you thought that necessary connections were there in the mosaic, then it is stripping that out. But even in science, there's a distinction between, people don't think of like causation and laws as like this kind of stuff that's there in the mosaic. They think of that as more part of the representational machinery in describing what there is there. And so it's reflecting a distinction that I think is already there. And for me, this has always been the heart of why I wanted to be a Humean, is that I think, if modality is either in the world, it's in or us, or in the relationship between us and the world, I think the third. And so I've always been a kind of Humean in this sense. Okay, so I already said that. But then you can, oops. What's that noise? That's not me, is it? But then you can imagine, this other type of humanism, where you start thinking about not laws and that, but start thinking about ontology, Ouroboros humanism. So the snake or serpent eating its own tail. And in this kind of humanism, what you're doing is you're using the systematization strategy to attack the mosaic itself. And so the systematizing snake has turned on itself and is eating its own, actively trimming the mosaic. In a kind of sense, you're systematizing twice, once deciding what ontology to keep, and then once to get the laws, etc. And so in this way of doing things, what you're doing is you're removing bits of the mosaic. Where what I mean by the mosaic right now is just the sort of ordinary interpretation of the ontology given by science, if it exists, which of course in quantum mechanics is going to be a problem. So you're applying the systematizing strategy to the mosaic, and you're systematizing away the world. So you're taking these little bits of little tiles that you originally thought were there, and then you systematize them out. Sometimes it's completely uncontroversial. So we systematize out jerk, snack, crackle, and pop. That's the third, fourth, fifth, and sixth. Those are the names of the third, fourth, fifth, sixth derivatives of temporal derivatives of position. It's completely uncontroversial. No one thinks crackle is down in the mosaic. You systematize it out. It's one thing that might make you think it's uncontroversial is that crackle is related by logic and definition alone to other things that you might think are in the mosaic, position and time. And just by logic and definition alone, get those out. But logic and definition alone isn't enough to really make you, if you want to use that as a criterion, that's not really enough, because, if you think about the case of instantaneous velocity, Instantaneous velocity is related by logic and definition alone to the position developments through time, if we're imagining a classical world. But then you think of the debate there, if you think of Arntzinius' paper on instantaneous velocities, you can see that it's not sufficient, just being related by position development, by logic and definition alone, is not sufficient for a lack of controversy, because it could be that you worry about, you want to put velocity in because you don't have a good explanations of things if you don't have it there at the bottom. And so even though it's related by logic and definition alone, you might want to still include it. And arguably it's not necessary, just like in regular Humeanism, where the nomology is not related to the basic ontology by logic and definition alone. And so classically, it's really what's going on is that jerk, snackle, crackle, and pop are not beables of classical physics because they don't do any work that isn't already being done by other things. But then sometimes it's controversial. And so you can see a kind of buildup happening through the last couple of decades. Well, if we put aside Russell. So if you think of Russell with the theory of velocity as advertising out velocity. But then, Lewis with chance in, I think, 2000, dealing with rotating disks. I systematize out, well, you could think of it as, it could be angular momentum. Ned Hall, he doesn't endorse, but he suggests, he uses it as an example. You could do it with mass. Nick Huggett does it with inertial frames. Then we Bohmians do it with the quantum wave function. And then you get to Superhumanism, where you do it with you systematize out basically everything. So now the serpent really has eaten the mosaic almost entirely, except for some dots. In that picture, there are dots that are blue and black, I believe, but in Esfeld's picture, they would not have different colors. And so then, not too surprisingly, people have objected and said, this time, Humeans, you've gone too far. And so here's a whole bunch of different papers and reviews saying you've gone too far. There's a whole bunch of different objections, and not too surprisingly, I don't agree with a bunch of them, but I do agree with the main thrust of these objections. And that is, do you guys hear that dog? Okay. Can you quiet the dog down? Okay. It'll set off the other one, and then it's like they're like Dumb and Dumber, and they'll just ratchet each other up. Anyway, this kind of objection is, Neil, puts his finger on it, I think, with the idea that this is just so cheap, and it really, this kind of systematizing away, you could just do this anytime. And Dustin also, there's just sort of, the objection comes, the objection really comes in different ways, but it's sort of the same thing, I think, that you really, it seems like you're doing a priori physics. You're deciding what there is, and then you're running with it. And you could always do this with any physics. You could pick any type of physics you wanted. As Neil points out, you could be, instead of a Bohmian, you could be a Berkeleyan. I forget how to say it, but you could, get rid of the physics and just be a phenomenalist. It could even, go even further. You could be a kind of solipsist. Say the best systematization of the appearances. If I had full information, I don't really know what that means in the solipsistic world, but if I had the best systematization of my solipsistic experiences is maybe this fundamental equation right there, and and then I'm deciding beforehand what there is. And boy, this is objectionable. If you're a human, you are probably a Humean because you didn't want to, you probably have a streak in you that's strongly anti-a priori physics, and here you are doing a priori physics. You think, what the hell has happened to Humeanism? I got into it because I didn't want to do that kind of thing, and all of a sudden now I'm up to my ears in decisions about what there is in the world. Really, I just want to react passively. You tell me what there is in the world, and then I yank out the modal from the non-modal. So you could do all sorts of different strategies. It could be anything, right? So here's the world, nice pastoral picture, but maybe you hate sheep, and so you just get rid of them, right? So you just systematized out the sheep. I mean, why have them? It's more parsimonious. A world without sheep is clearly more parsimonious than a world with sheep. And sheep, they're smelly, and those ones in the pictures look really nice, but the brutal reality of a sheep is not so pretty always. But now, you got rid of the sheep, but now there's all those, look at those sheep shadows. Right? There are those sheep shadows in this world. And so you have to explain the sheep shadows. And so now you're going to have to put in some initial conditions. Now you're going to also have all these kind of correlations between, the impression, the forces on the grass, where with the four legs pressing on the grass, and those things tend to hang out with the shadows, where the shadows are, and we have to start building all that stuff. And so as I do, then things are going to get more complicated. I'm going to have to build in some boundary conditions and really special initial conditions. And then as I think about the different, if you think about sheep special sciences, there'll be all sorts of regularities there. And then those I'll have to further constrain the state space of how my sheep shadows behave with one another. And it's all going to become an ugly mess. Same kind of objection, David Albert makes this a kind of objection in response to a back and forth on his book with me. And he says, why don't we just, you suppose you had a Hamiltonian with a collection of n Newtonian billiard balls that interact with each other just, through elastic collisions. And, there's n of them, but you had a kind of hankering for fewer than n. And so you just, systematize out the ones you don't want. And then you have a kind of law, at the bottom of that quote there, it says, a certain motion of the first m balls is physically possible if and only if there is at least one solution of the n ball equations of motion, of which the m ball motion in question forms a part. So you could just let n be 2 and m be 1. And, you could say, well, I really don't like, consider a world with just these two particles interacting. And, I just don't like that one on the right. So I'm going to say the real beable is the pink one there. Now, again, I'm going to have to explain why did that pink one turn to the left? Well, it's just part of the structure of the phase space of this of the nomically allowed system. The nomically allowed phase space is going to push this thing over like that, but there's not any kind of reason. So this is really unsatisfactory, this kind of strategy. So if we want to, and so what he objects to is that, in terms of the fundamental ontology, if you did this, there's going to be no initial value formulation. So initial value formulation means that, when you formulate things in terms of the, if you put it in terms of the fundamental predicates of the theory, then from a time slice, you can, if you have from a complete information on a time slice, you'll have existence, uniqueness, and continuity of solutions. And here, just from the information of about the pink one at that time slice, when it intersects the gray instantaneous state, you don't have enough to tell you that it's going to go off to the left at all. And so it's, really not very nice. You could also think about this kind of scenario. It's kind of fun to think about this strategy that David imagines, because you can then think about all the different other things that you'd be unhappy with. because you like to think that you exist, you're a potential observer, you're made up of beables, but then, there's your friend. And so, maybe, so it seems very arbitrary to select me. Maybe I'm not, maybe it's not particles, maybe the pink thing is a trajectory of, say, me, and the black one is, say, Al. Then, why would I exist and not Al, fundamentally? And so I could also imagine him, putting the pink on him and the black on me. And so you have this kind of arbitrary selection of things, which is also going to lead to, not very, you're not going to see reflection of the various symmetries of the system in the fundamental stuff. So it's really going to be a pretty ugly system, very much like the sheep. Al, in his review of the Superhumanism, mentions benzene. And can you explain benzene and all the chemical properties that benzene has from the Esfeldian, just the positions and distances? And he says, no, the state space of benzene does so much explanatory work here, and all the charge, the energies, all this stuff does so much work here. And so it's kind of similar point that the state space that is imposing a lot of explanatory structure. I put this with Ouroboros because just as an aside, the person who discovered the ring structure of benzene, if people don't know this, he described it, and you can read about it, where he was having a dream, and he dreamed of Ouroboros, and the serpent eating itself, and he then ran to his. When he woke up, he realized he had discovered the structure of benzene, and then wrote it all down, and so nothing. Okay. Now, what you can see then, you've got all these choices, and you can see these choices being operant in the foundations of quantum mechanics, where then we don't have a clear ontology. And so you can then look in different cases where you have different choices. And it's interesting to see that in foundations of physics, people will make this kind of distinction. So the questions of how far along the line do we go? So on one end, we've got skepticism. On the other, we don't systematize out anything. Both seem mistakes. So where do we go? Where in between is the appropriate spot to land? And it's really an ongoing question. So if you look at Ward Struve's work on quantum field theory in the pilot wave approach, it's really wonderful. And he points out all these different ways that are empirically adequate to different choices of beables that will be empirically adequate, and yet they're paint pictures of very different worlds. So I won't go into this, but these are pictures from his paper. But if you look down at the bottom there, so this is what he's drawing pictures of what's really real according to each of the different choices. And down at the bottom there, you've only got the magnetic field and the interferometer, and then the radiation coming off of things. And it's going to be empirically adequate, but then he says, no, this has gone too far. This is even though it's empirically adequate. Same thing if you look at GRW. This is one of my favorite diagrams. So the GRW is a realistic collapse theory, and it posits two different parameters that would be new fundamental constants of nature. And then you can see, what they do is they look to see where GRW is, when will it be ruled out, if it's ever going to be ruled out. And so ERR is the empirical region where we've done tests and we know the parameter is not there. But then PUR stands for philosophically unavailable region. And so here there are physicists who are pulling out a parameter, points in the parameter space that are philosophically terrible. So they're empirically adequate, but philosophically terrible. Why philosophically terrible? Because in some cases it'll make it so that the collapse happens way, like in your eye or something when you look at something. And so then the external world is not really there until you look. And then that's philosophically objectionable. And so so what I'm trying to say is that, in this kind of spectrum between the skepticism, the solipsist whipping out a massive wave equation versus the not systematizing anything out, we want something like what these physicists are getting at, something in between there. And so you can see what's going on is there's all these different criteria that people are using. The Esfeld and Decker criteria is very minimal. They're saying that the measure for ontology is simplicity together with empirical adequacy. The worry about that is that criteria is so weak that it also allows skepticism and other things. But you can see that the David Albert and other objections are about the initial value problem. So you should have enough to have an initial value problem. But I would extend that and say really just even best explanation. So if it didn't satisfy just an initial value problem is a pretty technical thing. You could have good explanations and not have an initial value problem. You could also have a picture that is a little bit more like Struve's, I think, which is that minimize the cognitive distance between manifest and scientific images. You see this in some of Tim's Mauldin's work. Okay. How much time do I have, Al?
That's a very good question. You can go on 10 or 15 minutes longer, Max.
Okay. I just want to Okay. So now let me turn to the Bohemian interpretation of the wave function and see with that kind of set up, let's see where that stands. I had to reproduce this slide I did from the talk before, so some friends didn't realize that was me, and it made me realize that to many people I'm just a pair of glasses, and I take my glasses off and they don't know who I am. But anyway, Bohemianism. Well, for me, when I was thinking about this, I wasn't thinking about a Humean supervenience really at all. For me, I was just trying to solve what I thought of as this kind of two-space problem. So you've got the wave function living in Hilbert space. You've got high-dimensional space. You've got the particles living in 3 space, and you've got this kind of Cartesian dualism interaction problem. How do you have this stuff from upstairs interacting with the stuff downstairs? If you like, you can also put it in terms of the wave function in terms of a complex scalar field on a configuration space. But again, you still have the same problem because then it's R to the 3n somehow interacting with R stuff in R3. That's really weird. It's highly undesirable. I think it's a major problem. It's always bothered me about the Bohm interpretation. You could try to do different sorts of ways to put them in the same space. So you can move everybody downstairs, upstairs, like David Albert does, and talk about a Bohm world particle living in R to the 3n. Or you could try to, squish the upstairs, downstairs, and give every particle a wave, like Travis Norson does, put it all in R3. Because of the non-separability and non-locality and all that stuff, you're not just giving each particle a wave, though. You've also got waves over those waves, and by his own admission, it's very ugly. And of course, in philosophy, there's been a lot of discussion of the Albert picture about how to get the kind of manifest image out of that very far away scientific image. So you could then eliminate one type of ontology. So you could just keep the wave function. If you don't have a collapse, then you're Everett type picture, or be a Bohemian. So Bohmian is like the opposite of Everett, so you've just got the particles and you've gotten rid of the wave function. You've systematized it out. And, so you systematize it out and get the wave function just from the particles. Very attractive. Now everything is in one space. And then in the paper I wrote on this, I then showed, in detail compared the classical to the quantum this way. So what I did was I put put classical mechanics in a wave function formulation, which, so you can find there's a classical Schrodinger equation, and so you can look at psi as it evolves according to this classical Schrodinger equation. You could then compare that to the quantum wave function, and it's really pretty elegant and cool, because what happens is, as you know, you could also write things in terms of a Hamilton-Jacobi equation, and then when you you can write Bohm's theory in terms of a Hamilton-Jacobi equation, and so you put psi in polar form, throw it into the Schrodinger equation, separate real and imaginary parts, and then you get a Hamilton-Jacobi equation modified by quantum potential, and then a continuity equation. And then what's really cool is in the classical case, you can take this classical wave function, you put in psi, REIS, separate real from imaginary parts, and what happens is you get the Hamilton-Jacobi equation and then a continuity equation. And the thing is that in the classical Schrodinger equation, there is the only difference between it and the Schrodinger equation is that there's the quantum potential. The Bohm quantum potential is there. And so what happens is the Bohm quantum potential basically moves from one equation to the other. And then you think, well, if that's the only thing that happens, then why did I get all so upset about things, about where the wave function lives? Because I don't say the classical wave function lives. There's no, everyone wants to systematize away the classical wave function. But why not do the same then with the quantum wave function? And so you have all sorts of benefits. So you don't have an emergence from the high dimensional Bohm world particle. You've got connection to 3 and 4D symmetries that people complain about that you don't have on the kind of Albert picture. You don't have this action-reaction principle problem because there's no there's no wave function beable to worry about having action-reaction with. There's no redundancy problem. So when people say that Bohm is Everett in denial, now Bohm it's full-throated anti-Everett. And then, the classical transition is then kind of interesting because it's then one of, you have the same ontology, but just different laws. So the stuff behaved differently than we thought, and we organized it and systematized it differently. So very nice, beautiful, but it's got problems. So here are 4 problems, and I'll only, I really want to just spend time mentioning, talking about the last. First, there's this idea of the contingency of the wave function. So you see Albert and Brown and Wallace make these kinds of objections about the contingency of subsystems and also about time dependence. Well, I think this objection can be answered pretty nicely by appealing to the effective versus universal wave function division. I do that in a paper. Other people have done that too, so I won't talk about that further here. But the rough idea is that, just as children don't have to look like their parents, effective wave functions don't have to look like their universal big mother wave function. So in particular, as many people showed, way back in the early 90s, you could have a time-dependent effective wave function, even if you have a time-independent universal wave function. And so you can have all sorts of differences between the effective versus the universal. There's a question of supervenience. I don't really have anything super better to say about it than what's been said about it. So Elizabeth Miller talks about this. Many of you in the audience have talked about this. Thomas has a really beautiful paper about this. he puts it as an objection to Bohmianism, but there are various bullets he admits you could bite. And since I'd already bitten those bullets, it didn't seem to come across as a criticism to me. But I will just quickly mention, that, so this question about, well, you have a lack of supervenience between the, when you think about the singlet state versus the triplet state, if you go back and look at the debate about rotating disks, I think you want to say the same sorts of things. So that, the idea was that rotating homogeneous rotating disks would be a counterexample to Humean supervenience. But when you really think about it, those rotating disks, the rotating one, if it's like a sphere, it doesn't go oblong, it doesn't have any effects whatsoever. And then it makes you think, well, if I'm a Humean, why the heck would I even attribute rotation to that thing? The rotation really becomes more like ghostly, adding a ghost to it or something, because it has no effects whatsoever. So then why would I ever attribute that to it? And so it's only in sort of worlds like ours where there's also an environment where it would then show its effects. Only in those cases would I want to say that one of the disks was rotating, the other one not. Same kind of thing here. Why would I say that one is, one of these systems is singlet versus the triplet state? I would not, unless I was also thinking about the environment and the effects and the actual measurements that happened in this world or similar ones. And so that one doesn't bother me so much. Then let me advertise, so another big issue we saw with the sheep case, if we were imagining getting rid of sheep, how complicated the physics would have to become to really get rid of them. Same objection has been made here against Humeanism, that the initial wave function is going to be super, super complicated. And then why think that that's going to be part of the nomology? That, if you're a systematizer, you like, one thing that a good system prizes is simplicity, and yet you're now proposing to add something really very, very complicated. And so this is a big problem. I mean, we don't really know what the universal wave function, how complicated it is, but presumably it's very complicated. But here I'll just advertise my colleague Eddie Chen's work. And in particular, I mean, we could have seen his work on the initial density matrix hypothesis. He's got it in a couple of papers, but I'll draw your attention in particular to his newspaper, where he makes all the connections to humanism, directly. And so I think that would be a good way for a Bohemian to go in order to deal with the simplicity problem, which I think is a really big problem. Okay. Now, but there is a big difference between the two. So you can go to my paper, One World, One Beable, to see more about the initial value problem. But the big difference is that, despite the fact that you could try to make those two theories, classical mechanics and quantum mechanics, look so similar. I can put them both in Hilbert space, do both wave function stuff. I can put it all in Hamilton Jacobi. I can make them look so similar you can barely tell the difference, and then you think, well, what is it that makes a big difference between the two of them? And the answer really is that what it is to determine motion is different. If you break up the wave function, the classical wave function, into r to the EIS and the quantum wave function to r to the EIS, there's a huge difference, which is that the r and s are coupled in the quantum case and uncoupled in the classical case. That what looks like a small difference turns out to be huge. And so, but I don't want to go into the technical stuff. Just give a couple of examples just so you can get a sense of what the problem is, and see that really it's just like the sheep again, or just like Albert's case again. And so I want to say, this is really that the Bohemian is really guilty as charged of this. So here's a fun little example, which is imagine a bone particle in a box. It's still, there's no forces, so there's no potential, V is 0. And so I confine it to the box that's just sitting there. It's just sitting there for all of time. And then I move one of the sides of the box. What's going to happen? The bone particle is going to start to move over toward that side, even though there's no potential there. Now, every ounce of you is going to want to scream, why? Why did the particle move over there? There's no reason for it to move over there. And yet, without the wave function, you don't have a well-posed initial problem, just in terms of the particle, of course. And so you have no real answer as to why this happens. It just had to happen for it to be empirically adequate. Here's another, So it's a bit like what happens in Newtonian gravitation theory. If I change the mass density, then due to Poisson theory, the Poisson equation, I change the field instantaneously. But then that's why we posit the potential as real, right? It's to get rid of that. And so you can so what I'm trying to do is say, forget about the technical stuff about whether you satisfy an initial value problem or not. There's just normal explanatory reasons for wanting to posit something. So same sorts of reasons that made you want to posit the gravitational potential are sorts of things that would make you want to posit a wave function or quantum potential, which comes to the same thing in this kind of case. And then here's another case. Here's another example, which I think is cute. Imagine again now we have a bunch of bone particles in a one-dimensional world. And now imagine they're all moving over to the right. They hit the barrier. The first one hits the barrier. The one all the way to the left starts to go to the left. As soon as the one on the right hits the barrier and starts to go to the left. So they're going along, and as soon as this one hits and starts to reverse, they all start to reverse. And they think, well, why the one all the way on the left start to reverse? The physicist Wyatt says, like well-mannered guests at a cocktail party, they keep a polite distance apart. The answer is because what's happened is the wave packet has hit that, and then everybody traveling along with the wave packet then starts to reflect. But that one on the left, it didn't hit anybody. It didn't even hit the wave. It didn't even hit the barrier. It didn't even get close, and yet it starts to go off to the left. Again, why did it do that? You want an explanation? The natural thing to do, I want to admit, is to introduce the quantum potential or wave function as the explanation for that.
Great. Okay. If we're going to have any discussion, we should probably wrap. Great. You're at the conclusion.
Yep, I'm on the conclusion. Yep. So the criteria of simplicity or parsimony together with empirical adequacy allows us to go too far. Their boldness, Esfeld and Deckert's boldness showed us what going too far looks like. But what further criterion should we insist upon? An initial value problem is a natural one. We don't want to say a priori that that physics has to be structured such that you have this 3+1 formulation. On the other hand, you do want, in these kind of cases, an explanation. On the other hand, here, the cognitive distance between the manifest and scientific images is also a desideratum, and yet, we saw in the alternatives to Bohmianism, where things were in different spaces or all upstairs, then we had a lot of cognitive distance, and so what we have is what theoretical virtues we add to Esfeld and Deckert's criteria are up for grabs, and also they can sometimes conflict with one another. So I want to say Humeanism strongly violates a central desideratum, no question. But how to weigh this against its other benefits is not clear, especially when the further theoretical virtues conflict. Thank you.